Hi, everybody. We are the NASA capstone team, and we'll be presenting to you today our proposed solution pertaining to long-term risk mitigation when selecting a potential project for our organizational sponsor, NASA Lane. Before we get started on our insights, we'd first like to introduce ourselves as well as thank our sponsor and faculty advisor. Hi, my name is Claire Limpus, and I graduated from Virginia Tech with a dual undergraduate degree in management, HR, and poli-sci philosophy and economics. Currently, I'm looking at opportunities pertaining to consulting and data analytics.
My name is Jake Dixon. I graduated from New Jersey Tech in business with a concentration in entrepreneurship. I'm currently pursuing opportunities in consulting and business analytics.
Hello, I'm Jeff Stepien. I completed my undergrad here at Virginia Tech. I got my Bachelor of Science in Management Consulting and Analytics. Upon graduation, I'll be working as a life sciences consultant at Astria, New Jersey.
Hi, my name is Chris Nelson. I also completed my undergraduate degree at Virginia Tech in business management, minor in computer science, and I'm currently exploring opportunities in product management and data analytics.
We would also like to take this time to thank our sponsor, Dr. Stephen Fair, as well as our faculty advisor, Professor Kendra McKinley. Thank you both so much for your continued encouragement and assistance through each step of this process. Thank you so much. We couldn't have done it without you. NASA Langley's current process of selecting a project utilizes a 5x5 matrix, which the resulting score of said model indicates the total amount of short-term risk a project may incur. This is where our opportunity gap originates. We are proposing that there be an additional 5x5 matrix model that runs parallel to the original, but focuses on the long-term risk. By implementing this new model, this will better optimize the project selection process for NASA end users. And now I'll hand this off to Jeff to discuss the current risk framework.
Thank you, Claire. Now, before we get into our proposed solution, we're going to first go over the current risk framework that NASA uses, which is the 5x5 matrix. The 5x5 matrix uses likelihood and consequence and scores both of them on a 1 to 5 scale. The product of these values then returns a risk score. Green signifies low risk, yellow signifies moderate risk, and red signifies high risk. Now, this current framework is very effective. It's widely used across NASA and its different departments and research centers, and it gives a way for different teams and departments to have conversations about risk perception and severity. Through our research and different interviews with stakeholders, we found some room for growth for NASA, how NASA currently looks at risk. We want to try to find a way to have more of a financial lens with how they view risk, and we also wanted to find a way to see how risk can evolve over time if a project isn't done by a certain point. And we want to try to link both of these together to get the most strategic way of viewing different projects and their risk. So that led us to creating our foundations of our proposed model. We want to create something that went along with what NASA currently uses, but create something that is more actionable, more comparable, and more value-driven. This led to us creating the features for our solution. We want to create a parallel risk model that went along with the current model. We didn't want to make something completely new and want to have something that was easy, with an easy learning curve for NASA end users. We also want to create time value adjusted risk scoring, understanding that if a project isn't done by a certain point, the risk for it may drastically increase over time. We also want to have cost-based risk prioritization, understanding when the best time it is to invest into a certain project. And we also have a value index calculation that fits seamlessly in with NASA's current tools, ensuring that end users understand what they're looking at and how to use it. I will now be handing off to Jaden to go over our proposed solution and all its components.
Thank you, Jeff. Now, when a project is entered into the risk register, it can be graded following one of two different paths. For projects that are short-term in nature, they will continue to be measured using the existing 5x5 matrix and scoring methodology. But now for projects that are long-term in nature, they will now be measured using our new long-term 5x5 risk matrix. It was important that both these matrices output on the same 1 through 25 scale to ensure easy comparability between all projects. The key difference between the two matrices are the variables used on the axes to measure those values. Aggregate value score is a measure of how much money can be saved by executing on a project, and aggregate risk score is a measure of how much risk can be avoided by executing on a project. After our model runs, it will generate two key values, one being total currency saved over a 15-year span if a project is executed now, and the other being a total risk score mitigated by executing on our project now. Our model will automatically assign these two key values a score 1 through 5 for use with our long-term matrix. And we built this score to propagate throughout the rest of the risk register where applicable, so that this project can be compared with every other project in the risk register. Our model will also output a chart showing the cumulative costs incurred over time for the two scenarios where the project either is or is not executed. It becomes very evident whether there is or is not significant cost savings attributed to executing on a given project. We can do the same thing for risk, showing the cumulative risk score incurred over time for the two scenarios to determine whether or not there is or is not significant risk score savings attributed to executing the project. Now I will now hand it off to Chris to speak on the anticipated economic impact of our solution.
Thank you, Jade. To demonstrate the impact of using this new solution, let's consider 3 different hypothetical projects that could benefit from using this new approach. Starting off with the maintenance of vacuum spheres at NASA Langley Research Center. Over time, the paint that covers these vacuum spheres degrades and needs to be replaced. There's an opportune time to do this where it would only cost around $400,000, but risk hasn't increased that much if you forego that maintenance. If you continue to forego it, the risk eventually increases and the cost increase as well. Cost can increase exponentially up to around $1.6 to $3.2 million in some cases. So if you delay that maintenance, which is very easy to do because the risk tomorrow is very low at the recommended time, it becomes significantly more expensive. Another example is the degradation of concrete foundations for wind tunnels. Over time, water can create very small cracks in the concrete foundation. That risk starts out incredibly low as the cracks are small, but they will inevitably get larger. For this example, the cost of intervention doesn't change that dramatically over time, but the risk does increase significantly as those cracks get larger, especially for machinery where precision is important, like wind tunnels. A less extreme example and a little more common would be something like the storage of fuel for backup generators. Over time, the fuel degrades. There's an opportune time to replace that fuel. That said, even at that recommended time, you can still use it with relatively low risk. But the longer you put it off, the more those risks go up, and cleaning out degraded fuel, sediment builds up, it's going to be a little bit more involved with process, costs a little bit more money, but a little less extreme. The existing process at NASA is unlikely to prioritize any of these 3 projects at the recommended time due to it only considering the short-term future of only what does it look like next year in terms of risks. Using our new system, which factors in the aggregate value saved and aggregate risk mitigated over a long time span, all of them have significantly higher scores, which leads to better visibility and a higher likelihood of being funded early. So some key takeaways. We designed this to seamlessly integrate with their existing system, which allows for easy tuning and maintenance by NASA staff in the future as they adjust and continue to refine this model. It also integrates well with efforts being made for future digital modernization by groups like Pixis, who are creating dashboards and other standardizations across NASA. And by using this new process, portfolio managers will be able to better prioritize long-term projects, which will allow them to save millions in projected long-term cost savings. If we use the example of just the vacuum spheres, it would have cost $400,000 to repaint versus over $1 million if you delay it far enough. And that's just one project. If you apply this to all of the dozens of projects that are being assessed every year, you can see how these savings can add up, and that doesn't even factor in the risks that's saved. Some advice for Cohort 10, identify your data needs early. It can take time to acquire that data, especially if it's sensitive and it needs to be cleaned. Always have a set agenda, never show up without a game plan. Take pride in your work and really get to know your peers. This is a small program, you're only here for a year. It goes by way faster than you think it does. Get to know each other, lean on each other, and you'll have a great time. Thank you all for listening to our presentation. It's been a pleasure working with NASA over the last year, and we will open the floor for Q&A. Yeah.
Curious that those will get incorporated.
So all of the data is being manually entered in by engineering teams. When one of their managers fills out the risk forms for a project, they'll update that every year, every 2 years, and that's how that will be updated over time. One of the challenges with this project was limited data. That's why we ended up using case study hypotheticals, because due to the nature of some of these projects, we were only able to see synthesized data based on realistic projects in the past from our sponsor. So those kind of models are something that might be able to be explored on NASA's side, but from our end, we provided the base framework to start that process.
How does your model handle discounting for time?
Our model does utilize net present value, and it uses a user selected hurdle rate. The hurdle rate just being the agency decided upon interest rate they want to use to discount these values. It allows them to fine tune just how much they want the future to impact the model.
How might the implementation plan look like for rolling out?
So our recommendation is to start out with a small pilot at one facility, see how it performs. Again, we're going off of hypothetical data, which was approved by our sponsor, but you really need to back test it, look at previous data, and then run it in a real environment. So start off small, do a pilot program, see how it performs. NASA engineers can very easily tune it, like you're saying, adjust those hurdle rates so it properly accounts for the long-term time. And we've been told that NASA Langley is actually planning to use it in their next planning cycle, so we're very excited about that. And if that goes well, then they'll roll it out across other facilities in the agency.